Okay, so we have seen a lot of simulation of smoke management and evacuation. It's time to talk about structural resistance of structure. I'm a civil engineer, I'm a fire engineer, so then we can couple the capability of one person on both projects. That's always nice. You do the change, okay. Today we'll talk about a transformation of an existing tunnel in Switzerland. This transformation is made in the remit of a tramway project. So we have to check the fire safety for the evacuation and the structural fire resistance. That's what we have done. The evacuation has been done by another company. In Switzerland, since until 2004, there was no explicit fire duration requirement for tunnel structures. So by that time, we didn't know what to do with this project, and the requirement was often R60 or maybe sometimes R90 minutes. And for this project, we have to ensure a safe evacuation and no structural collapse because the tunnel is under the airport, taxiway, and runway. And we should have no significant deformation. The tunnel is made of prestressed concrete structure, and the main structure consists of a double span, a big slab that's supported by reinforced concrete walls. And the main resistance capability is done by a 100% base design, prestressed base design for the transversal direction. To make the model easy to analyze and design, we have simplified the model. When you do structural analysis, it's always nice to make simple model because they're easy to understand and to check. If you do 3D model with the soil, all the constraint and the pre-stress cable, often you don't understand anymore if the model is correct. So we will put the pre-stressing force into the model by a method that is called substitute force. Maybe in English is not the correct word, but that's, you can understand as the cable has parabolic curve, they will put away the weight on the top. Before doing some structural analysis, we have to make a model, and always we do 3 verifications as a structural engineer. We have to check if the model stands up in cold situation with real forces and real action, and then we do the thermal calculation. So we start with identifying the section for the slabs. So we have 3 sections for the slabs and 3 sections for the walls. In the reinforced concrete, we have few rebars, so most of the resistance is assured by the prestressing. For the fire action, we rely often in Switzerland with a French guide. It's called Guide de Sécurité pour tunnel routier. Is giving some example, and we have this normalized fire curve that you can find in any publication. And these files are adopted in Switzerland too. So it's easy to start. Into this guide, we have the heat release rate curve for different vehicles, heavy goods, vehicle fire, fuel tanker fire, and thermal fire. That's what we will have in this tunnel. For the thermal calculation, we have to check the sensibility of the structure, and you can see on this tunnel, this is the place where the cable is the nearest to the fire position. So this will be the critical section to check. We will check this heating at different depth into the concrete, starting from 3.5 centimeter until 11.5 centimeters in depth. So we start with the thermal calculation. We always start with isofire calculations. We can rely on some result, and we can quickly understand if the calculation is correct or not. As you know, the steel and concrete, they will lose capability of during the heatings. So we will use the Eurocode curves that are inside the Sapphire software. As we didn't put the cable into the model, we have to make assumption on the replacement forces that we put into the model. So we have to do an analytical calculation of the evolution of these forces that we put in the model in order to take into account the losses in strength and yield. So with the cable, we will have, with the heat, a thermal elongation, so the cable will be longer. And as the Young modulus drops, we will lose the strength and the forces in the model. So that's how we do consider the heating of the prestressing cable into the section. So the first result, we have here the heating of the cable depending of the depth into the section. And on the right-hand side, you can see that we are losing a lot of kilonewton in the section. So if you lose the prestressing forces, then your tunnel will beginning to go down. We put this evolution of the forces in the structural model, and then we will consider the other section being heated. But that's one of the results of the calculation, that the tunnel is deforming quite a lot. So we cannot reach 60 minutes resistance with the first calculation, is isofire, and RWDS fire too. So in both cases, the tunnel will collapse. To do further with the analysis, we have made an FTS model. It's about 90 meters long, 600,000 cells model with a few meshes. And we have put the RR curve into the model for 164 megawatts. We took the real tests from the full-scale tests in Sweden, that we have one example of the curve, and that's what we got. We got temperature, adiabatic temperature on our model inside. So with this temperature, adiabatic temperature, we will extract the results and put them to the section that we consider in the structural model. When you do FTS thermal calculation, you get this, and it's sure you cannot use all this data to hit a section for structural, so you have to take one envelope, and the worst, we took the least and the worst temperature and put into the model, and then at the end you get the real envelope curve of heating inside the tunnel. With this new calculation, we can prove that in any way except the tramway scenario that will have a collapse in the tunnel. So we cannot afford to have a collapse in the tunnel, as is under the airport. And in our consideration, we have chosen that we will have no spalling before 600 to 800 degrees. So what are the solutions to cope with this situation? One of the solutions was to restrict the traffic and to have no heavy goods vehicle and non-fuel tanker in this tunnel, so they must take another itinerary. We can have passive measure. We can put fire panel on the concrete. And active measure, we are thought about one good solution could be water mist installation. So the passive measure, when you put panel on your concrete, you can see you have a big drop in the temperature here. From 500 degrees, we drop less to 200 degrees on the surface temperature, and this is very effective. That will be a good solution to avoid the spalling in the concrete, because once you have the spalling, the rebar and the prestressing steel will be more exposed to temperature. But this is not enough. You can see here the places where we think this is good to have passive measure, so to put fire panel, but not into the whole tunnel. Passive measures are good, but you don't have the best solution for your tunnel, because you can see with no fire panel, you have a big deformation. With the fire panel, you have less deformation. But you have advantages, it's reliable, you have no maintenance, it's very efficient, and you have a good feedback. And you can protect the concrete from the spalling. The drawbacks, this very expensive solution, it's about 450 euro per quadrat meter. In 500 meter tunnel, you can calculate easily that it will cost more than 3 million euro to install. If you have a fire, all the installation, technical installation from the tunnel that will be replaced next year have to be replaced again in case of fire. And the fire panel of the fire have to replace all the fire panel that have been damaged. And you have no cooling effect on the fire. So our proposal for the client is to add a water mist system to the tunnel. You all know how it works, our water mist. I will not explain to you. We want to have a strong cooling effect on the fire. So we will have a section, a 20 meters section on the tunnel with water mist installation. So in case of fire, 2 to 3 sections will be effective. So we will have 40 to 60 meters of effective water mist on the event of fire that will have a strong cooling effect on the tunnel. You can see that some experiments done by companies prove that this is very effective at time of the activation. The heat release drops significantly and goes down. So you don't extinguish the fire, but you have a really cooling effect. So the temperature in the tunnel stay low. So when you have an active measure, you have a lot of advantages. Limited fire development. It's very easier and safer for the firefighting because the temperature go down and then they can go safely into the tunnel. And we have a low damage risk for the tunnel and the structure. So the fire will go down, you go really colder, and you save your tunnel. That's the most important thing, that you can have a fire, but your tunnel is not very damaged. And some drawbacks is very reliable. You have 10 to 2% risk of the installation is not working. You can have some damage to nozzle and some smoke destratification for the evacuation, but we have done discussion with the evacuation engineer, and we think that is not a real problem. So the result from this study is the current structural situation is unacceptable in case of fire. We cannot have huge deformation or collapse of the slab, so we have to close the airport for days or many months. And we need to improve that, so we proposed a mixed solution. So we will put fire panel in the most sensitive part of the structure and add a full water mist system coupled with a smoke, thermal, and camera detection in the tunnel make the measure more effective. So the performance-based design approach offers the best solution for the client to improve the safety and the structure and guarantee the airport operation. I hope you understand everything, and I'm open to questions.
We have some questions here.
Yeah, thank you for the interesting talk. I actually have two questions. So first would be, so for pre-stressed concrete, the question comes up, what type of composite do you have between the steel cable and the concrete? And do you somehow consider the friction and how it's affected by the fire or by temperature at all?
So I think at that time, because it's made in the 60s, it's fully injected cable.
Okay.
So the cable is like part of the concrete section. There is no,
okay,
no
just
slipping.
So you just consider it as in standard steel and concrete?
Yeah, yeah.
Okay.
We cannot change it. Even if it slips something, we cannot change the system because it's already done.
Yeah, okay.
Yeah.
Thank you. And the second question would be, so especially for high temperatures and intensive heat exposure in tunnel fires, the spalling of concrete is a relevant thing. Yeah. Did you somehow consider this in your thermal section when calculating the temperature on the steel?
No, we didn't, because it's quite complicated. You can make a lot of assumptions and you don't know if they're correct or not. And the cable were very close to the concrete. So if there is spalling, the risk is there. So we speak with the client and the other civil engineer. We have to protect the very sensitive part of the tunnel. We cannot have spalling in this tunnel. It's already a critical situation. So we have to protect the very sensitive section of the tunnel
so
with panel.
So you're ensuring that you have a minimum cover of the steel at this point.
Because 3.5 centimeter for prestressing is really not enough. Should be 7 or 8 or 10 centimeter normally.
Yeah. Okay. Thank you.
Yeah.
Thank you. Anyone else? Questions? Okay. Okay. Oh, we had one come in, yeah. Which criteria was used as failure in the modeling? Runaway deflections?
Mostly it's deflections, because once your tunnel is deflects too much, you cannot repair it, and you can understand that the plane cannot stand with non-plane surface. So maybe 1-2 centimeters, okay, but more than that is not good for the airport. And then the model showed that there will be a collapse, and inside the tunnel you cannot repair it. It's too complicated.
This may be a very naive question.
Okay, that's okay.
I know nothing about tunnel fires. But you mentioned that the cost of the protective covering, the passive covering, was like 450 euros per square meter. Yeah. What was the saving of the introducing the water mist? I may have missed that. Yeah, I didn't explain everything, but if we protect everything, it costs about 3 or more millions francs. If we put only the water mist, it costs the same. And the mixed solution costs the same with more benefits. So we only protect part of the structure. Right. So we protect only some of the part of the tunnel. So it's a partial passive protection and a full mist, a water mist. So for the same price, at the end, we have a better protection.
Very nice presentation.
Thank you.
I know nothing about concrete pre-pressed, but regarding the evacuation and the time that is left for evacuation in tunnels, when you mix water mist, the smoke stratification might be a problem with the egress. Have you considered checking a sweet spot to leaving a gap between the operation of the nozzles to allow for egress?
So as I said, only a small portion of the tunnel will be with water mist. So if the truck is 15 meters and will be in between 2 or 3 sections, we will have maximum 45 to 60 meters with water mist. So people will not stay in the fire, and the water mist will go very fast on the side. So we think this is not a problem. Very fast, the visibility has been checked by the other engineer. That will be okay.
Okay, thank you.
Okay.
Yeah, and there's a related question here, I think in a similar theme, which is with the recommendation of using water mist, what was the design airflow velocity used during the pre-fire activation and the fire activation?
I think the other company made calculation with 1 and 3 meters per second wind. They made the assumption. It's a pre-project. It's not yet to be constructed. When it will be approved by authority, we will make the final design. But we show that it should work. The current situation is very dangerous. Once happens something, it will be very bad for the airport and the safety. So maybe next time I will present the actual final project.
Okay. All right. Well, thank you very much, Eric.
Thank you.